We are going to start chapter 1 of college algebra. So this is the beginning of the material that you're going to be responsible for, and as far as with the lecture videos. And so let's get right to it. So we're going to cover linear equations today. So we're going to cover basic terminology of equations, linear equations, identities, conditional equations, and contradictions. Solving for specified a variable, what we call literal equations. And so now here are examples of some equations. And so what is the definition of an equation? An equation is a statement that that makes two expressions equal. Okay, so it's a mathematical statement that says that one mathematical expression, or algebraic expression, is equal to another algebraic expression. For example, here this equation says that x plus 2 is equal to 9. And this equation says that this polynomial, this quadratic expression, is equal to 0. Okay? And so when we solve equations, what this means is we want to find all of the values of x in this case that make the statement true. Okay, so we want to know, hey, what values of x make this side equal to this side? And those are what we call the solutions, or in other words, the roots of the equation. Okay, so a number that is a solution of an equation is said to satisfy the equation. And the solutions of an equation make up its solution set. Okay, so we can have one solution, okay, or we can have more than one solution, or we could have no solutions. Equations with the same solution, so if we have two equations and they have the same solution set, we call them the equivalent equations. Okay, so here are some properties. So we have an addition and multiplication properties of equality. Okay, so now what this means is if we have, let A, B, and C represent any real numbers. If A is equal to B, okay, then if we add C to both sides of the equation, then the resulting equation is still true. So if this is true, then this is automatically going to be true as well. Okay, so it means that, hey, if we have a true statement, if we add the same constant to both sides of the equation is unchanged. It's still the same. Okay, so this gets to the point where, hey, whatever you do to one side of the equation, you have to do to the other side. Okay, now addition and multiplications as well. So let's look at multiplication property. Okay, let A, B, and C represent real numbers again. Now, if A and B are equal and C is not equal to 0, then A times C is equal to B times C. So again, if you multiply both sides of an equation by the same number, it will still be equal. Okay? As long as it's a non-zero number. Okay, linear equations in one variable. What does that mean? It means that we only have one variable in the equation. The equations that we've seen so far are all examples of a linear equation in one variable. Okay, so this is a general form here. So ax plus b is a linear equation. So a linear equation means that it's in one variable, but it only has an x. No x squared, no x cubed, just x. And of course, b can be 0, but a cannot be equal to 0. Okay, a and b are real numbers, but a cannot be equal to 0, because if a is 0, then we no longer have a linear equation. We just have a constant. Now, a linear equation is also called a first degree equation because the degree of the variable x, or y, if it's y, is 1. So the exponent, so what we're talking about is the exponent. The exponent on the variable x, or y, if it's a y variable, is 1. So for example, these are linear equations. Okay? This is a linear equation because the exponent on x is 1. This is a linear equation. This is a linear equation. Okay? Look at, there's two x's, but again, it's linear because the largest exponent on x can only be 1. Okay? Now these are nonlinear because here x has a square root. So this means that the exponent is what? 1/2. Okay? Here x is in the denominator, which means we can write this as what? X to the -1. Okay? And then this is x, the largest value, the largest exponent here is 2. So the degree of this equation is 2. So this is nonlinear as well. So those are examples of nonlinear versus linear. Okay, so let's solve this equation. So here we're going to, now we want to solve, right? So now that we know linear equations and we know what an equation is and we know the properties, let's solve. So we're going to use the properties to solve an equation, okay? So we're going to take this as an example. So what's the first thing we're going to do? Well, we have to use the distributive property here, okay? Notice that we've got a 3 here, so we got to get rid of these parentheses, right? And so the way we're going to get rid of these parentheses is by using the distributive property. So we have to use the distributive property here, and we have to use the distributive property here. And some of you might say, well, why do we have to use the distributive property? Because, got to be careful of the signs. So this is like a -1. So if you think of a -1 here, like, so you're multiplying by a -1. So you'd have to distribute the negative to both of these. So it'd be a -5 and a -x and a -5. Okay. So this side is easy to see because of the 3. But if you just have a subtraction, remember, you're subtracting the whole thing, which means you have to distribute the negative sign, right? And change this to a subtraction. So it'd be negative minus a negative, or just subtraction and subtraction. Okay. Now, then we want to combine like terms. So how do we combine like terms? Well, we can do it on this side by adding the constants, right? So we get 7 minus 5 because of the subtraction. So 7 minus 5 is 2. Okay. And now what we're going to do is we're going to use the properties to solve for x. So we're going to add x to both sides. Why? Because we've got 6 x's over here, 6x. We've got minus 1x over here. So let's move this x over to this side. So what we're going to do is, since we're subtracting, we're going to add. So we would do the opposite because we know that minus x plus x is going to give us 0. And then whatever we do to one side of the equation, we have to do to the other side of the equation because we don't want to change the equation, right? So we want to add the same thing to both sides. So then we get this, right? So then this x adds with this x, and we get 7x minus 12 is equal to 2. So now we want to move this over here. So we're going to add 12 to both sides. Okay. And then so what do we get here? This is going to give us 0. And this is going to give us 14. And now we get 7x is equal to 14. Now, what do we have to do to both sides to get x by itself? Well, this is 7 times x. So what's the opposite of multiplication? Division. So we're going to divide by 7 because 7 divided by 7 is what? 1. And then we'll just have x. But whatever we do to one side of the equation, we have to do to the other. So we're going to divide both sides by 7, and we get x equals 2. And so x equals 2 is the solution to this linear equation. Now you can verify this, and I highly recommend that you verify this by taking 2, plugging it in for x on both sides of the equation, and see if you get the same thing on both sides. Well, here you get 4 minus 4, right? You get 4 minus 4 is 0, and then so you get 0 over here. And here you get what? 2 plus 3 is, or excuse me, 2 plus 5 is 7. 7 minus 7 is 0. So you get 0 equals 0, which is true. Okay? And so that's what we're going to do. Gotta check. And we get a true statement. And so the solution set is this. Now, if I ask you for the solution set, you have to use the curly braces, because the curly braces is the symbol for a set of objects. So in this case, we have a set of numbers, and the only number that's in there is 2, which is fine. So we have this curly brace, 2, and then the curly brace, okay? Or bracket. Okay, now let's talk about solving equations with fractions. Okay, so now that we did an example where we have whole numbers, let's talk about what if we throw fractions in here. Well, what we're going to do is find a way to get rid of the fractions. Okay, so how are we going to do that? What we're going to do is multiply by the least common divisor. Okay, the least common divisor for all of the divisors. So what are the divisors? 3, 2, 4, and 3. So we want the lowest common divisor for all of these. Well, 12 will be it, because it's the smallest number that is a multiple of 3, a multiple of 4, and a multiple of 2. Okay, so that will be the lowest common divisor that we can use. Okay, or the lowest common denominator. Okay, the least common denominator is what, I'm sorry, I misspoke. The least common denominator is what we were saying. So the least common denominator is the smallest denominator that we can get, a common denominator. Okay, so what do? We distribute 12 to all of the terms within parentheses. So we're going to multiply this side by 12, and we're going to multiply this side by 12, right? Remember the property. And then we're going to use the distributive property, and we're going to basically divide everything by 12. And watch what happens. All of these fractions will go away. Okay? Because 3 divides 12, 2 divides 12, 4 divides 12, and 3 divides 12. So guess what? We're going to divide. And all of these fractions are going to go away. And so 12 divided by 3 gives us 4, so we get 4 here. 12 divided by 2 is 6. 12 divided by 4 gives us a 3. And 12 divided by 3 gives us the, well, in this case it'll be 4. But then 4 times 7 is 28. So this is what we have. Okay? So now we're going to distribute. So we distribute the 4, right? 4 times 2 is 8. 4 times 4 is 16. Okay? Now what we're going to do is we're going to combine like terms. So over here we're going to combine the 8x and the 6x to get 14x. See, they changed the t. That's a typo. D should be x. That's funny. So now it's simplified to 14x plus 16 equals 3x minus 28. And so now what we're going to do is now we're going to move this over here, and we're going to move this over here. So we want to get all the x's on one side, all the constants on the other side. That's what we're doing. And so in order to do that, we've got to, in this case, subtract 3t, excuse me, 3x, I'm going to keep it with x, from both sides. Okay, so if I subtract 3 from both sides, I get 11x over here. There it is. And if I subtract 16 from both sides, I get what? I get negative 44 here. So I get 11x equals negative 44. So what am I going to do? I'm going to divide both sides by 11, right? Because I need to get rid of that 11 and make a 1. So 11 divided by 11 is 1. So, but again, I have to do it on both sides. And so I get x equals negative 4. Okay? And then, of course, we want to check, right? Take negative 4 and plug it back in for x. Wherever there's an x, we want to replace it with negative 4. Okay? And then we want to see if we get equal on both sides. If we get the same number on both sides, then we verified that it is a solution. Okay? So what do we get? We get negative 8 plus 4, which gives us negative 4 over 3. This gives us what? Negative 4 divided by 2, which is negative 2. This gives us negative 1 minus 7/3. Okay? And we get negative 10/3 on both sides. And it's true. So the solution set is just the set of the number negative 4. Now, an equation satisfied by every number that is a meaningful replacement for the variable is an identity. And so an identity is true no matter what x is. Okay? In fact, you always know an identity because what happens, x will fall out. X will disappear. Well, in this case here, if we distribute the 3, we get 3x plus 3. So we get the same thing on both sides of the equal sign. So in other words, no matter what x is, it doesn't matter. Whatever we plug into x, we'll always get the same thing. So that's an identity. An identity has an infinite number of solutions. This is a conditional equation. Conditional equations are equations that are satisfied by some numbers. Okay, so it does not have an infinite number of solutions. So there may be one, there may be more than one, but there's a finite number of solutions. Okay, so it's conditional because sometimes x is a solution, okay, whatever number you put in, and sometimes it's not. So it's conditional. It's conditional on what you plug in for x. So in this case here, 1 is not a solution, but 2 is. Now, a contradiction is never true. So this is like the opposite of an identity. Identities are always true. Contradictions are never true. Okay, so these are sort of like anyway, I don't want to get into the splitting hairs, but anyway, in this case here, there are no values of x that we can plug in and get the same thing on both sides. It's impossible because if we plug in 0 here, we get 1 here. If we plug in 1 here, we get 2. We get 3, 4, 5, 6. So 6, 7, 7, 8. So we'll never, ever, ever get the same number on both sides. So this is never true. So it's a contradiction. Okay? So anytime you get something where, and another way to do it is, look, if you get rid of the x's, okay, here's the easiest way to do it. Just subtract x from both sides, right? What happens to the x's? They go away. What do you end up with? You end up with 0 on one side equal to 1. Well, 0 equal to 1, that's a false statement. So it's a contradiction, okay? With an identity, if you distribute, like in this case, and you get rid of the x's, you get 3 is equal to 3, which is always true, right? Regardless of what x is. So that's how you can easily tell whether you have an identity or a contradiction. Okay. If you get x equals 3, if x doesn't drop out and you get x equals 3 or x equals something or other, then you know it's a conditional statement. Okay, now here's what we want to do. So we want to determine whether this equation is an identity, a conditional equation, or a contradiction. Okay. So let's solve and see what we get. Okay. If we get the same thing on both sides, it's an identity. If we get different things on both sides, right, then it's a contradiction. If we get x is equal to something, then it's a conditional. So let's solve, right? So let's use the distributive property. Okay, so make sure you distribute the -2. So we get -2x minus 8, and then plus 3x, and then x minus 8. And now what we're going to do is we're going to simplify this and see what we get. Okay, so immediately we're going to add like terms, and what do? We add the 3x and the -2x. And what do we get? 3 plus a -2 is what? Just x. And so we get x minus 8 equals x minus 8. And so this would be what? An identity. Because we get 0 equals 0. And it's always true. Okay? So when true statements such as 0 equals 0 or 3 equals 3 or -4 equals -4, then the equation is identity and the solution is the set of all real numbers, or we could use the bold-faced R. So you'll see me write this most often is a bold-faced R. Okay, so you'll see me write that. Okay, so this is also, you could write the set of all numbers with the braces, or you could write the symbol and it's the set of all real numbers. Okay, so now what about this one? Well, look at this. Well, let's solve for x. What do we get when we add 4 to both sides? So we're going to get rid of the 4, so we're going to move the constant over here. And so we're going to add 4 to both sides, and we get 5x equals 15, right? And then we divide each side by 5, and we get x equals 3. And so guess what? We solved it, and so this is a conditional solution. So this is going to be true when x is equal to 3, and it'll be false otherwise. So that's a conditional statement. Or a conditional equation, rather. Now, what about this one? So here we're going to do the same thing. Simplify this thing and see what we get. So we're going to distribute, right? So that's the first thing we do is distribute. And what do we get? We get 9x minus 3 equals 9x plus 7. Well, that's definitely not the same. But again, if we subtract 9x from both sides, we get what? -3 equals 7, which is never true. Right? That's a false statement. So this is a contradiction. Okay. So we would say that the solution set is the empty set, or also called the null set. And the null set is symbolized by just a 0 with a slash through it. Okay. Okay, so identifying types of linear equations. So one, if solving a linear equation leads to a true statement like 0 equals 0, then it's an identity and it has an infinite number of solutions, okay, or infinitely many solutions. If a solution set leads to a single solution like x equals 3, or it could lead to, oh, these are linear equations, so never mind. It'll only be one solution. So with linear equations, it's either going to have no solutions, one solution, or an infinite number of solutions, or infinitely many solutions. Okay. 3, if solving a linear equation leads to a false statement like -3 equals 7 or 4 equals 2 or anything like that, it's a contradiction and it has no solutions. So the solution set is just the empty set. Now, solving for a specific value for linear equations. Okay, a formula is an example of a linear equation. Okay, an equation involving letters. That's all a formula is. Okay, or an equation is an equation involving letters. A formula is an equation that involves letters. Okay, and where you plug in values for these letters. in different circumstances. So we're going to talk about simple interest. So simple interest is a way of figuring out the amount of interest on an investment or a loan. Okay, and so like for example, if you borrow money from your friend and he says, well, I'm going to charge you 6% interest for the loan, and you need to pay it back in a year. Okay, so this would be the equation you would use to find out how much interest you would end up paying your friend at the end of 1 year. Okay, or if it was 2 years. Okay, so I is the variable that represents interest. That's the amount of interest. P is the principal amount, or the loan amount, or the investment amount. So this is typically called the principal, but this is the amount that you're investing or the amount that you're borrowing, depending on the situation. Rate. R is the interest rate. Okay, this is an annual interest rate. Okay, both of these units must match. So if this is in years, this must also be in years. So this is usually percent per year, and this is obviously number of years. So now here we want to take this formula, okay, and we want to say, I want to solve this for t. What that means is I want to get t by itself on one side of the equal sign. So again, we're going to use our properties that we learned earlier in this video to do that. So what are we going to do? Well, we want to isolate t to one side. So how do we do that? Well, we're multiplying by p, this product here, because this is all multiplication, right? P times r times t. So if we want to get rid of the PR and move it over to this side, well, we're going to have to do the opposite of multiplication, which is division. So we're going to have to divide both sides by p times r. And of course, this side becomes 1, right? P times r divided by p times r is 1. Okay, and so there you go. So now we know how to solve for t. Now, this next formula is the future value formula, or the maturity value of having p dollars invested for 2 years. And this is also simple interest. So this is basically saying, hey, if I have a simple interest rate or a simple interest loan or an investment and I'm earning simple interest on it, how much money am I going to have after so many years? Okay, or so many months or whatever. Well, this is the formula we're going to use. Okay, and it's really nothing more than just the principal plus the interest. That's all you're doing. Remember, interest is PRT, right? So if you distribute the P, you get P here, and then over here you get P times RT. So it's actually just whatever you borrowed or whatever you invested, and then you're just adding the interest, okay? But this is the formula. So this is the future value. So this is the amount of money you'll have, or the amount of money you'll owe, depending again whether you're investing or borrowing. And then this is the principal amount, and then this is the rate in years, per year, the annual rate, and this is the number of years. So now what if we take this and we say, hey, I want to solve for P. Well, so if I take this and I solve for P, right? So I want to solve for P. Well, what they do is they distribute the P, right? So let's say you have this, let's say you're given this, and they say, okay, I want to solve for P. Okay, well, what are you going to do? You have to isolate P to one side. Well, I've got P here and I've got P here. So the first thing I need to do is I need to get P all to one side. So I'm going to add P to both sides here. And so now I get this. And now what's going to happen is I'm going to now use the distributive property and factor out the P, because I've got a P here and a P here. So I can factor out the P, and I'll be left with 1 here, and I'll be left with RT here, because I can look at this as 1 times P. So if I factor out the P here, I'll be left to 1, and here the RT. And now what I can do is divide both sides by this quantity. And so I get P is equal to A divided by this. Now notice that if I'm given this, I had to do some extra steps. Okay. Now, what if I have something like this and I want to solve this thing? Okay. Well, let's solve for x. So again, use use what we need to use. Okay. The order of operations. So here we're going to use the distributive property. We need to get rid of these parentheses. We need to get rid of those by using the distributive property. Then we're going to add like terms. Okay. And so in this case here, the only difference is that our final answer is not going to be a number. That's the only difference. Our answer is going to contain constants and letters. Okay, but we're still going to do the same thing. We want to get f isolated to one side of the equal sign. And so the first thing we're going to do is distribute the 3. Okay, so we get this. Now we're going to what? Isolate the x's. We're going to move the x's over here, and everything else goes to the other side. And so I subtract 4 from both sides, and now I'm going to add 15a and then subtract 4b to both sides. And we get this. Okay. And now what I'm going to do is add like terms. There are no like terms over here, so I don't do anything with this. But I do have like terms over here, so I'm going to combine these. So it's going to be 6 minus 4. So I get 2. So now I'm going to have 2x is equal to this. So now all I have to do is what? Divide by 2. And I'm going to do that to both sides. So I'm going to divide this whole thing by 2. And so this is my solution. This is the way I would leave it. There's no more I can do to further simplify this fraction. Okay, so this is the way I'm going to leave it. So now, word problems. Okay, so let's now use what we learned about simple interest and solve a word problem. So a woman borrowed $5,240 for new furniture. She will pay it off in 11 months at an annual simple interest rate of 4.5%. How much interest will she pay? Okay, so what's the interest after 11 months? So a couple of things one thing to make sure, well, a couple of things. The first thing is remember the interest rate is annual interest rate, so it's 4.5% per year. But notice that the amount of time she's going to have the loan for is in months. So we've got to convert that to years. So how many years is that? Well, so we're going to have to change that from months to years. Well, we're going to have to, how are we going to convert it? Well, we use the fact that 1 year is equal to 12 months. Okay, and so 11 months is the same as 11 twelfths of a year. So we're going to have to divide it by 12. So 11 divided by 12 will give us years. Okay, and then we also have to drop the percent sign and change that percentage to a decimal. So the interest rate has to be in decimal form. So it'll be 0.045 when we used it in the formula. And so we're going to use I equals PRT. And so we're going to, the principal, what's the principal amount? It's the $5,240. The rate is 0.045. And the time is going to be 11 divided by 12. And now all we have to do is plug it in. Okay, so there's our information. Now we're just going to plug in the values, just like that. And now we're going to just plug it into our calculator and get the answer. And so we round to the nearest penny unless otherwise specified. So it's going to be the amount of interest for the loan that this person will pay is $216.15. That's it. Okay, and so that and that finishes this section. So again, please make sure you're watching these videos before class. Also, make sure you practice. Go over these, take notes. If you get stuck, write that question down. If you have questions, bring them with you to class. Please make sure you're doing this, okay? Practice the examples. There are other examples in the textbook. There are exercises at the end of each section or chapter, okay? So make sure you practice this. If you get stuck on something, bring it to class. That's where we're going to do the work. That's where we're going to practice as well, okay? But you have to do some of the practice outside of work. Remember that 2-to-1 ratio, okay? So we're going to do work in class, but you've got to bring your questions. You've got to bring your knowledge of what you learned, your notes, and be ready to jump in and start working. Until then, have a great day. Bye-bye.